Okay, so yesterday we introduced being able to make a reflection, and the reflection itself is a mirror image. It's a flip across either the x-axis or the y-axis because those act as our mirrors. Well, today we're still going to talk about that, but it's not so much about how to do it, it's about what the rules look like. And this is where it gets a little dicey, so follow with me. Let's first see if we can figure out the rules ourselves. So if I look at, let's talk about the x-axis first. Okay. So here's my x-axis, that's my mirror. P is originally -4, 3. Well, when I go across the x-axis, which is 3 spots away, and I go on 3 on the other side, it changes to -4, -3. And I'm going to go back to this to reference our rule. Q is 3 spaces away also, so I go 3 spaces away on the other side. Well, originally Q was 2, 3. Now it's 2, -3. And then R is 2 spaces away from the x-axis going upward, so I go 2 spaces on the other side, and it ends up being -2, 2. But let's talk about the rule. If P was originally -4, +3, and now the new P is -4, -3, which one changed? Did you catch it? Because what changed was the 3. It went from +3 to -3. Well, look at Q. Q was 2, 3, and now it's 2, -3. Well, which one changed? Again, the 3 changed. R was -2, -2, and now the new R is -2, +2. Which one changed? Did you see the pattern? Because what you notice is, even though I reflected across the x-axis, it wasn't the x number that changed, it was the y number that changed. And that's going to become important here in a second. So think about that for a second. Let's talk about the y-axis. If I highlight the y-axis as my mirror, A was originally -2, 1. Well, when I go across the y-axis on the other side, it ends up being 2, 1. B is originally 1, 3, and now it's going across the y-axis, it's -1, 3. And C is originally -1, -3, but when I go across the y-axis, it's 1, -3. So let's compare. A was originally -2, 1, and now it's +2, 1. Which one changed? This time, the 2 changed. B was originally 1, 3, and now it's -1, 3. Which one changed? Well, the 1 changed. And C was originally -1, -3, and now the new C is 1, -3. Which one changed? The 1 did. So notice the pattern. Even though I reflected across the y-axis, it was actually the x value that changed. So this reflection rule is what I call opposite day. Because even though I reflect across the x-axis, it's not the x that changes, it's the y that changes. So the y becomes positive or negative in this case. And even though if I reflect across the y-axis, it's not the y value that changes, it's the x that changes. So I think about reflection, a way to remember it is opposite day, because it's opposite of what you actually think it is. So let's keep that in mind. Now, when you come to your paper today, it's just going to ask you which reflection it is. So we're going to think opposite. You ready for it? First things first is you need to know the quadrants, because it's going to ask you some vocabulary. Quadrant 1 is top right. Quadrant 2 is top left. Quadrant 3 is bottom left. Quadrant 4 is bottom right. So we're going to use this as a reference as we go through it. Okay. It says, if I reflect a figure from quadrant 1 to quadrant 2, which axis did I reflect over? Well, the line between them is the y-axis, so we reflected across the y. Number 2 says 0.35, so think about where 3, 5 would go on our coordinate plane. It would go in quadrant 1, is reflected into quadrant 4. Well, think about it. If I go from quadrant 1 to quadrant 4, which axis did I reflect over? That would be the x-axis. Now let's talk about the rules themselves. My point was originally -6, -1. The new point is +6, -1. I want you to circle which one actually changed, because it was the 6 that changed from -6 to +6. Which one is that? Well, 6 is in the x position, but it's opposite day. So even though it's the x that changed, I reflected over the y. And if that did not make sense, then you can always use your quadrants as a reference. So think of it that way too. Let's talk about the next one. It was 10, -3. Now it's 10, +3. Which one changed? Well, the -3 became +3. Well, what position is the 3 in? That's the y position, but it's opposite day. So even though the y is the one that changed, I actually reflected over the x. And again, I can use this as a reference. If I'm not sure what the rules mean, 10 negative 3 is in quadrant 4, 10 positive 3 is in quadrant 1. I went from quadrant 4 to quadrant 1. That's the x-axis. So 2 ways to go about it. If I look at this one, it was 2, 7. Now it's negative 2, 7. Well, which one changed? The 2 changed. Well, the 2 is in the x position, but it's opposite day. So it's not the x that changed. It's over the y-axis. If I look at this one, 10 negative 5 became 10 positive 5. The 5's changed. Well, the 5 is in the y position, but it's opposite day. So if the y actually changes, it means it's actually a reflection across the x. It was 2, 11. Now it's 2, negative 11. Which one changed? Well, this would be the y changed. But because it's the y that changed, that actually means it reflected across the x-axis again. Then you're going to see somewhere I give you an image. Which axis did these triangles reflect over? Think about that. Which axis is between them? That's your x-axis. That's your answer. On this one, which axis is between the two reflected images? That's the y-axis. So don't miss those. They're pretty easy. Negative 3, 2 to positive 3, 2. Well, which one changed? Well, the 3 changed. What position is the 3 in? The x position. But it's opposite day. So even though it was the x that changed, it actually means it's a reflection across the y. So you've got to think opposite day when you're talking about your rules.